we've all, we have at home, right? We use for baking and things like that. You know what else we use baking soda for? Making the what, Salvin?
Our fridge.
Yeah, you put a box in your fridge and it kind of absorbs odors in it. So there's a lot of different properties that go along with baking soda.
Solid.
Yeah, it's a solid. And then vinegar,
Liquid.
right, liquid. And vinegar in kind of chemistry terms is a dilute solution of what's called acetic acid. Right, so it's actually an acid. So what I'm going to do is go ahead and I'm going to pour that in. Put it out. Right? I like the word extinguish because what does that remind us of? A fire extinguisher, yeah. So the gas that's here acted very much like a fire extinguisher. And that's actually the gas that they put in a lot of fire extinguishers. So the fire extinguishers that you see around, most of the ones around school are carbon dioxide fire extinguishers. We look at this on 3 different levels. The first level would be, well, what do we observe happening to this? Right, so we all see that. So we saw the bubbling, and the bubbling tells us that there's gas being given off. We know that we started with a solid and a liquid, right? And then what solid was white, the liquid was clear and mostly colorless, maybe a little tinted yellow, right? And then what we produced put out the flame, right? It was able to pour and put out the flame. So we learned some things about the products that would be informed. So that's what we see. The next thing a chemist would want to do is write out a description of that, right? Either in words or symbols. Okay? So I hold this pen, right? If I let go of it, what's going to happen? It's going to fall. So it's going to start moving, right? So right now there's the potential for this to start moving. i.e. potential energy. Just like on the ground. We want them to go up. Right? So we're going to need to give them some energy somehow. Right? So somehow this reaction happening inside your body, or inside your bottle, has to do that. Right? Our solid and our aqueous change into a gas. Gas inside there. So now we're getting back to kind of like what we see happening. So we see that buildup of pressure. We can feel the bottle and it's going to feel really, really tight. You're going to feel the pressure in there. And then when it releases, you're going to see the rocket go up in the air. Right? But ultimately that energy that's making the rocket go up comes from this reaction happening.
No, we should watch it at 6. I can bring it 6. Duct tape. And pull it around. Yeah, that's better. Perfect. No, we should decorate it first. Should we add a 4th pencil? Let me see it. So we can just wrap it around. So now do you want to make some guys need to reinforce it? So look, so I was thinking, No, I have an idea.
And then when it goes up high enough,
Okay,
the
yeah, I
corks
know
will like fall off, and then it'll start like going even higher. good. We're good.
Get the toilet paper.
Wait.
No, but
It's better without the cape.
No, you keep on my hand. Okay, Isabel, let me shake.
Okay, now let's put it.
I didn't get to do it.
When 7% was baking soda and 93% was vinegar.
The errors we encountered when we tested our rocket included the measuring errors, our hand reaction time, and that the cork wasn't in tight enough.
Reduce human errors by using computers to measure solutions to put the cork in and like an electronic shaker.
It'd be interesting if we found another to find another solution with two solids and a liquid to make the cork like build up more air and to make a gas and make it go higher.
A good follow-up question I had is if the shape of the bottle could make a difference in the height.
Experiment I would love to try is called a pipe bomb, and it involves baking soda and vinegar.
And then I would like to investigate would be able to see what kind of sails would push a boat faster.